we're going to find that problem 8 is a reasonably involved problem. And the reason it's an involved problem is because it involves finding the amount of drug based upon body surface area. So we're going to have to use our technique for finding the body surface area of a patient. The order reads as follows: Delaverdine, 220 milligrams per square meter. So as soon as we see that square meter, and that's the M with the little subscript of 2, excuse me, the superscript of 2, you're raising M to the second power, 220 milligrams per square meter. That immediately tells us that we need to be factoring in body surface area of the patient. The body surface area determines how much drug the patient receives. It says, how many tablets of this antiviral drug will you administer if each tablet contains 400 milligrams? Okay? So there's 400 milligrams in each tablet of the drug. And we want to know how many tablets then should the patient receive. And we're told that the patient is 6 feet 3 inches tall and weighs 150 pounds. So the first thing we need to determine is what's the body surface area of a patient with those dimensions. And again, the way we do that is we use our chart. So we need our chart, and we need a straight edge, and we would use the left-hand grid to give us the height. Oh, but the height is in inches, and we have feet in inches. So the first thing we'll need to do is to convert feet and inches to strictly inches. Well, each foot is 6 inches. If somebody's, each foot is 12 inches. If somebody is 6 feet tall, 6 times 12 is 72 inches, plus 3 inches more. This patient is actually 75 inches tall. So now we can use the chart because we've converted their height to strictly inches. We can find 75 inches, we can find 150 pounds, and we then read the center grid to give us the actual body surface area. And if we did that, we should find a body surface area that is approximately 2.10 square meters. And I say approximately because you're going to read something different possibly than I would or than another individual would. But as long as we're reasonably accurate, that should be sufficient for the problem. And of course we want to be as accurate as possible, but reading a scale like that, there's going to be some leeway, some difference. So we have a patient that has a body surface area of 2.1 square meters. So the first thing we're going to do is calculate the amount of drug that patient should receive because of that size. And the drug is administered at 220 milligrams for every 1 square meter of body surface area. So again, when we perform that arithmetic, we are finding the total amount of drug that this patient with this size should receive based upon that body surface area. So now we know how much drug. Now we just need to figure out how many of the drug in that form, how many tablets would we give them. And here's what relates milligrams to tablets. 400 milligrams or 1 tablet. I want milligrams to cancel the milligrams that are here in this numerator. I want to end up with tablets. So 1 goes with tablets, 400 goes with milligrams. And I have this arithmetic then that I would perform. 2.1 times 220 and divide that result by 400. And when we do that, we get, and as far as an arithmetic answer, we get 1.155. And that seems logical that we would then, administer 1 tablet? Again, you probably don't have tablets that you can divide so as to give that amount, so it would seem logical we would go to the nearest whole number here. So this, again, was a little more complicated problem because we were figuring the amount of drug based upon the body surface area. And the first thing we had to do was use our chart, our nomogram, to find the body surface area for a patient of this size. Then we calculated the amount of drug, transformed that amount of drug into the correct form of tablets to answer the question.